Lesson 43 has two parts. The first part is on the least common multiple, and then the second part is on least common multiples in algebraic expressions. Well, first let's talk about what a least common multiple is. For example, if we had these two numbers, 2 and 5, some multiples of both of those, that's what we would think about first. So let's think about 2. 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, 2 times 6 is 12, and so on. So all of those are multiples of 2. And then 5, some multiples of that. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, and so on. Now if we're comparing 2 and 5, the least or lowest common multiple would be 10. That's the first multiple that we come across that they both have in common. So that's the lowest common multiple. Now we could continue on with multiples of 2, and we could go on out to 14, 16, 18, 20, and then on 5, 10, 15, 20 would be a multiple. So they both have a common multiple there of 20 as well. But that's not the lowest common multiple. So that's what we're looking for when we do least common multiples. Now when we have larger numbers like 20 and 14 and we want to find out what the lowest common multiple is for them, there's something that we do that helps us figure this out instead of having to multiply, do 20 times 1, 20 times 2, and so on to figure out what the lowest common multiple is. We can take the prime factorization of each number. So like 20, that would be 5 times 2 times 2, and then 14 would be 7 times 2. And then we take all the prime factors from each of those pairs of numbers. We have a 5 and a 7, and then 2, whichever one, we have 2 2's in the 20 and just 1 2 in the 14. Where it's repeated the most times, that's the one that we include to figure out what our least common multiple is. And so we would say 5 times 7 times 2 times 2. That's just equal to 35 times 4, or 140. So that would be the lowest common multiple that 20 and 14 have. And the way we figured that out is we broke each of those numbers in that pair into their prime factors, and then all of the different factors that they had, we use those and we multiply them all together to get our lowest common multiple. If both of them have the same prime factor, we use the one that is multiplied out the most times. So let's do some practice problems. In practice problem A, I have 3 numbers there, and I want you to find the least common multiple between those 3 numbers, 4, 14, and 21. So break each one of those into its prime factors. So 4 would be 2 times 2. 14 would be 7 times 2. 21 would be 7 times 3. Okay, now to figure out our lowest common multiple, we look at those prime factors. We see that there's a 2 is one of the prime factors. It's used twice. That's the most times it's used in a repeated fashion, so we would have to include that. 2 times 2 in our lowest common multiple. Then there's a 3, just 1 3, and then there's a 7 in 7 times 2 and 7 times 3, but it's just used once as a factor. That's the most it's used, so we just use it one time in our lowest common multiple. So then we have 2 times 2 times 3 times 7, which is basically 4 times 21, or 84. That's our lowest common multiple. Now the reason we're covering least common multiple is you'll be using this in some algebraic expressions later on. So that's why we're figuring out how to do this, and hopefully this is a review because this has been in previous Saxon textbooks as well. Maybe it's coming back to you now. Let's do one more. Find the lowest common multiple between 8, 65, and 230. So let's break each of those into their product of prime factors. So 8, that would be 2 times 2 times 2. 65, that's equal to 13 times 5, and 13 is a prime number. So we'd have 13 times 5. And then 230, well, we could do 23 times 10 23 is a prime number, and then 10 could be broken into 5 times 2. So we'd have 23 times 5 times 2. Okay, so now we go back and we recombine factors to make our lowest common multiple. And we look at our 2's, we have 3 2's multiplied together, so we would use that instead of just the 1 2 in 23 times 5 times 2. So we have 2 times 2 times 2 times 5, that's the most 5 is used as one time, times 13 times 23. Okay, so that's quite a large number there, and I wouldn't expect you to have to work out all the multiplication by hand. That's not the purpose of this. The purpose is to figure out the lowest common multiple. So you could just do that on your calculator. 2 times 2 times 2 is 8, and then times 5 is 40, times 13 times 23, that equals 11,960. Well, now that you know about how to do a least common multiple of just whole numbers, let's figure out how to do least common multiples of algebraic expressions. Now, one important aspect of finding a least common multiple of a whole number is if you're working with fractions and you find what they have in common so you can get a common denominator. It's the same idea with an algebraic expression, which may have whole numbers as well as variables included in it. So you want to be able to have something that you can have a common denominator for everything when you're working with fractions. So let's just use a simple example to start with. Let's say you had these two expressions, a squared b and ab cubed. And you wanted to find out what the least common multiple for those two were. Well, you do a similar process like you did with whole numbers. You can break them into individual factors. I mean, they're not prime numbers, so we can't really call them prime factors. But we would take the a squared and say a times b, and then ab cubed, we'd say a times b times b times b. And now we look at those two after they've been broken down, and we see that they both have an a in common, and we pick the one where a is multiplied out the most times, so we'd pick a times a. And then b, we'd pick out the one where b was multiplied the most times, and so we'd have b times b times b. And so there is our lowest common multiple, a squared b cubed. And just think about it. If you have these two fractions, 1 over a squared b plus 1 over ab cubed, and you wanted to add those together, you'd have to figure out the least common multiple for those denominators. And that happens to be a squared b cubed. So that means that on the left one you'd multiply by b squared over b squared, and that way you get a squared b cubed for the denominator. On the right you would multiply by just a over a, and then you'd have a squared b cubed in its denominator as well. Then you could add those two fractions together because they had common denominators. So look what I've written up there in red. That's something to keep in mind when you're finding the least common multiple for algebraic expressions. Just pick the variable that has the higher power or the highest power between them. So look at practice problem C. Find the least common multiple between those two algebraic expressions. Now usually on these the hardest part is finding the least common multiple for the numerical part or the whole number part. So we have a 3 and a 7 there. Those are both prime numbers, so we would just say 3 times 7 is 21. So the coefficient will be 21. And then for the variables, I mean, it's really pretty easy. You just pick the variable with the highest power. You have an a to the 6th and an a squared, so you would pick a to the 6th. Then you have a b to the 5th and a b to the 9th, so you pick b to the 9th. And choosing which variable or which power to use, it's kind of like the opposite of doing greatest common factor. In greatest common factor, you always choose the lower of the two. In least common multiple, though, you just pick the variable that has the higher power between the two, or if there's 3 terms you're comparing, then between the 3, just whatever. You just always pick the variable with the highest power to include in your least common multiple. Let's do one more. 8x squared y to the 5th and 10xyz to the 4th. We want to find the least common multiple between those two terms. So look at the whole number parts first, 8 and 10. And we could think, well, that 8, we could break it into 2 times 2 times 2, and the 10 would break into 5 times 2. And so we would use 5 times 2 times 2 times 2, or 5 times 8. So 40 will be the coefficient of this least common multiple. And then we look at the x's, pick the higher power there, so that would be x squared. Y, we pick the higher power, that would be y to the 5th. Z, we pick the higher power. Now look, there's no z in that first term, but actually there is, right? We could put z to the 0 there. And we always just understand that that means 1. So even if there's not a variable in one of the terms, we just pick the one that's to the higher power. Because if we were doing a fraction and we were trying to get a common denominator, we would have to have that z in the denominator. We couldn't just leave it out. So we'd say z to the 4th. And so that's our least common multiple. 40x squared y to the 5th, z to the 4th. And so like I've been saying, you'll be using this and applying least common multiple of algebraic expressions to adding some fractions or fractional algebraic expressions together in later lessons. Okay, well that's all for lesson 43.